window?
We certainly can. And recording has started, so thank you and take it away.
So today I'm going to talk about Simbachain, which I'll refer to as Simba, which is a small firm that I work at. And we're going to specifically talk about what Simba's been doing, what our product is, a little bit of our history, and then some trends that we're seeing and what we anticipate moving forward with. I'll also refer to some of our big projects that we've done and let you know about some interesting recent developments. If you don't know me, as my grandmother always used to say, well, then you're missing out. I'm Victoria Adams. I've been in the blockchain business for about 7 years now, and I guess it's been good for me. So let's just get going then. So first, I'd just like to introduce Simbachain so you understand what we are and where we came from. So Simba was born in 2017 from a DARPA Phase 1 SBIR grant to the University of Notre Dame and a local business, ITAMCO. Essentially what we had was a professor from the University of Notre Dame, Dr. Ian Taylor, who was interested in blockchain, and then the CEO of ITAMCO, who was interested in crypto. And the two got together, responded to a DARPA grant about secure messaging on the blockchain. Ian, the professor of computational science at Notre Dame, looked into it and said, you know, this is a lot more complicated than it needs to be. And from that, Simba was born. What we've done since is to develop a low-code blockchain as a service platform that we call Blocks. And that chain is there, and that application is there for building chain-agnostic blockchain solutions. We've been very successful in raising capital between our Series A round and various other venture capital rounds. We've raised about $37.5 million to date. And we're looking forward to closing our B round either later this year or early next year. We've had dozens of successful government contracts, SBIR 1s, 2s, 3s, which are very rare, which means anybody can reach us, basically anywhere in the government. And it's a single source, a sole source rather, direct to us to do blockchain work. Recently, we've won the Air Force StratFi, which is a $30 million Air Force contract, which is kind of between an SBIR 2 and 3 as an attempt to assist commercialization. So half of that 30 million comes from the Air Force and the other half from the private sector that has contributed to the project. And that will be in effect to build a blockchain for DoD, or really a blockchain for the Air Force that will be open to DoD. So we have proven technology. The government, you know, has been very nice to give us more than $50 million in funding from DoD, DOE, USPTO. So that's been very good. We've been successful in enterprises with Boeing, Tox, Dow, Caterpillar, Mantech, and you know, we used to try to really focus on education, although we've backed away a little from that because frankly, it just takes a lot of work to enable them. And we're not big enough to do that, but we're the premier learning tool for blockchain at Ohio State, at Portland State, at California State. We've got more than 8,000 users and about 3,500 applications have been developed. As I said, we've done lots of work for lots of different kinds of people. You know, everybody from all of the branches, apart from the Coast Guard, of the armed services, to California, DMV, to Boeing, we're all over the place. And we've won quite a few awards. We're very proud of this. We won an award for as part of SBIR's TTR program as being a outstanding recipient of those funds. We've done a lot of work with manufacturing and won an award for that. And we were a gold medal winner at the Advanced Manufacturing Olympics that the Air Force sponsored. We've also developed quite a few unique technologies, and we've been awarded quite a few, well, we've submitted some and been approved on others, and a large number of patents. So we're very happy with what has gone on with that. And as I said, we've done all kinds of things for the military services, supply chain for the Navy and NAVAIR, financial tracking for the Air Force, asset tokenization for Space Force. I'll talk about that a bit later. And we're actually waiting to start doing some digital asset tracking with USPTO. So I want to talk about why we exist. What is the thrust and what's our value proposition to government? Now, we all know, and we've talked numerous times on this, this forum and many others, that there are tons of blockchain use cases in government. Supply chain, budgeting, identity management, payments and receipts, enhanced cybersecurity, awards and incentives, tamper-proof digital document and process tracking, fraud detection and procurement and contracting. We've seen these use cases referred to gosh knows how many times, but they're not happening. And we at Simba said, why? And essentially, we've come to the conclusion that blockchain has tremendous potential in government, but it's being held back by the cost and time of developing and maintaining blockchain applications, the fear of tech lock-in in a rapidly developing ecosystem, especially chain locking. Should I move to Hyperledger Fabric? Should I move to Quorum? Or is there some new super chain that's going to come out next year that makes these irrelevant? As we all know, there's a huge scarcity of skilled blockchain technical resources. You just can't get the people. It costs us a fortune. We're a small company. It's killing us. And the apparent complexity and novelty of blockchain creates a perception of a high-risk technology strategy. And finally, frankly, most government contractors lack blockchain experience. We've been very aggressively trying to sell to government contractors to enable them to be able to help the government. They just don't even often have the people to understand what we're selling. Not saying all, but I'm saying many. So if you're going to start developing a blockchain application, we found the problem is you need to know a ton of stuff. You're going to need to know Web3, Solidity, Girth, eScan. You're going to need to know how to configure Ether wallets. Need to know. And that scares people off. So what we've done at Simba is to develop a system that requires minimal blockchain knowledges that allows you to come in and be able to develop a blockchain application. So our solution is fast. You can move from months to minutes. We have estimated, based on the implementations we've worked with, that you can save up to 90% of the time and the dollars that are involved in being able to develop and implement a blockchain solution using Simba. It's tailored to what you need. You get what you need. You don't get a whole bunch of other stuff. It helps cut through the complexity, and it's future-proof, so it secures your investment. In other words, you're not locked into a particular chain, and it's secure and private. So we're providing an off-the-shelf solution to help you resolve those blockchain challenges. So again, our value proposition to the government is simple. We provide cost reduction. We future-proof the solution. We leverage your existing resources. Our platform allows you to upskill your Web 2 coders, the guys and gals you have now, and turn them into blockchain Web 3 coders with minimal effort. If you know how to code for Web 2, Simba will make it that you can code in Web 3. There are no maintenance costs. We take care of the maintenance and allow you to focus on mission delivery and your business. And finally, we're not just saying this, we've done it. We've got a proven track record of delivering compliant blockchain implementations to the federal government, both civilian and military. So that's our value prop. Cost reduction, future-proof, leverage existing resources, no maintenance costs, a proven track record of success. Now, I want to talk about some of our blockchain projects because I think this will sort of make some of this real. And then I want to show you very briefly what the technology looks like. Most of the projects that we've been working in are in the defense supply chain. And that is both a physical supply chain, tracking nuts and bolts, and a digital supply chain, tracking information, and critically, things like tracking designs for 3D printing. And what we're seeing within the supply chain are a number of generic problems. A dependence on non-US parts and materials. This is becoming more and more important with all of the various statutes that have been passed and regulations projects. The need to push, in particular, Chinese products out of the supply chain. That becomes very difficult because once you get past the first tier suppliers and you're getting down into the works, it's almost impossible to be able to identify Chinese parts unless you have some single source of truth that can be there. Now, the other thing that we're seeing is delivery bottlenecks and recurrent disruptions. Now, this wasn't just triggered by COVID. It's been emerging over a number of years, and it really comes from the just-in-time focus and the focus on most efficient producers, which has caused us to narrow our supplier base down. And that has ended up causing congestion at key points in the chain, and it becomes very difficult to know where things are. What we see within the military supply chain is this congestion builds up. You don't really know where something is. And so you just end up by ordering the same part again and again until it arrives. And furthermore, what we've seen is a range of different systems for tracking where a part is. These can be different companies, it can be logistics firms, it can be internal DoD systems, and with the proliferation of IoT devices, we're seeing a whole new set of silos emerging around those devices, which sometimes aren't compatible with talking to particular systems or have extremely poor security in themselves. And all this creates complexity and the lack of a single source of truth. You just don't know where things are. Now, originally, digitization and the migration to supply chain management online systems was meant to make this easier, but it really hasn't. It's created opportunities for hackers and fraudsters to compromise data. As I say, IoT has opened a huge gateway for fraudsters and hackers. The data silos that we know are throughout the federal government are the pain of our existence. I've been working for the federal government since the 1980s, and boy, this is a problem that never seems to go away. And the difficulty in understanding the provenance, where did something really come from? Has it been altered or modified? This is especially a big problem with digital files like you might use for 3D printing. And excessive data, so much data can be generated by these supply chain management systems that you really end up having a big problem figuring out what's going on. So you need that end-to-end view. Now, blockchain can help resolve these problems. It provides a single source of truth. I know where something is. I know the provenance. It establishes the golden record. We all know it's protected and secure. It's highly decentralized, difficult to hack. It can facilitate data sharing. We see this with nth tier suppliers, suppliers down the supply chain who say, I don't want to share my secret source, but I do want to try and share some things. So it facilitates that communication between systems, and it helps create trust and protect IP. So the typical system we're looking at, and I think this is sort of based around a medical system here. You know, we get the initial information gets onto the blockchain, all of the shipping through to a distributor, through to another shipper, through to a delivery to the warehouse, then on to the final point of sale. Yeah, this is a medical example. And we're able to use smart contracts to be able to pay the appropriate supplier and also to record it on whatever systems they need, with individuals who are touching the system also being identified. I personally feel that the supply chain problem is actually an identity problem. Who's touching it, both from a human point of view and from a machine point of view. If you can deal with identity, you can solve supply chain. So blockchain becomes very important. So now I just want to briefly illustrate a few examples. So Vipart was a project we did with Boeing and Naver. And Boeing used Simba to register and track components in an immutable, non-reputable way to verify the provenance of these parts from its end-chain suppliers going down the supply chain. And then Naver was able, we built a blockchain system using our platform for Naver that was then able to pull these data from different blockchains, from Hyperledger rather, which was what Boeing used, and the internal quorum chain that it was using. So it's pulling them from different parts and tracking the entire supply chain when it came to, I think it was the F-16, I'm not sure, that was going through an upgrade. More recently, what we've been doing with a project called DIGITIZATION, which is digital budgeting and tracking, has been to develop a blockchain tool that will actually tokenize dollars and will allow us to track expenditure of dollars down through the supply chain. And this will create real-time auditing and tracking of spending. And we'll have the ability to associate a specific budget authorization and allocation with specific purchases in the Air Force procurement and acquisition system. Typo there, apologize. Now, you know, DoD has never been able to develop a clean audit, and it probably never will. I don't know. But, you know, this is an economy. This is a spending on the size of Denmark's economy when you look at the whole of DoD. It's a huge thing. So being able to have a system which can create an auditable tracking of where dollars go, and also to digitize dollars, is pretty impressive. And this is really the core of what we're doing for the StratFi, to take this concept and expand it out through big Air Force that will then allow the final blockchain built by the StratFi will allow anybody in the Air Force to build a blockchain application on that blockchain and start to use that. So I think this project in particular, I find to be very exciting. You know, we've also been sort of very focused on creating these ruggedized platforms, you know, that are very secure. And one thing we did for the Marine Corps medical branch was to be able to create a system that provided real-time analytics by integrating into their analytics platform, and medical supply tracking. So you could track exactly where medical supplies were and link those to a patient. And what we also did with that was, by linking into the Marine Corps' systems, we could also link into triggers for different automation routines, different RPA routines. So that was a really interesting example of how security really can pay in for this. Basecamp was with the 448th Supply Chain Risk Management Group down at Tinker. And again, this is another provenance example. You know, we really were tracking microelectronics provenance. And we all know the danger of China getting into the supply chain there. We were able to identify counterfeit parts by figuring out where they came into it and then tracking sub-tier compliance. So were the lower level suppliers really abiding by regulation? So every time something came on to the passed from one state to another, what you had was that was recorded onto the blockchain. And with that data, we were able to map it, put it onto a real-time map visualization, and then also feed into business intelligence systems such that you could start to analyze these patterns and identify anomalies. And that proved to be very successful. The original thing that we did, the original project that we did that kicked this all out, was to try to create, well, we did create a decentralized mobile blockchain that provided peer-to-peer and end-to-end secure messaging, platform separated message creation from the secure creation of a messenger, of a message, which allowed this sort of knowing who started it off and then being able to track the message. And that really was the basis of things. Now, recently, we're working on a project from US Space Force for managing space debris. What we proposed to them was using blockchain to be able to tokenize space debris. And then from there, being able to create a registry that ultimately you might be able to create bounties for individual pieces of space debris. And to try and use novel technologies to be able to remove that debris. So this is very much a sort of proof of concept, thinking about it. It's a SBIR phase 1. We're working on it now, but I think it's a very interesting thing that's bringing crypto economics into the government to focus on what's really a very challenging problem. And then finally, with USPTO, we're really looking at managing digital assets. You know, that the patent and trademark system wasn't developed thinking about property, say in the metaverse. How will I deal with NFTs? So this is really sort of saying, how would you do that? And we're just starting on this project now, but I think this is very interesting, thinking about how blockchain can play into all of the different kinds of IP management that the federal government is currently facing. There was some more. I thought it was finally there. We also did some SBIR work with the Department of Energy to be able to create transparent, efficient processing of records when it comes to renewable energy. So again, you create this real-time auditable system that allows you to preserve the anonymity of anybody that's contributing different kinds of renewable energy to the grid. And this allowed utilities to be able to share information about the availability of solar power without, again, giving up their secret source. And so it's facilitating that data sharing. And then what we've also done is with the manufacturing and digital MXD program to create a local health system. And this translates real-time public health indicators into future demand signals that can predict supply chain needs. And again, it's keeping people's secret source, it's protecting consumer medical records, and it allows medical institutions to leverage big predictive modeling data inputs such that they can identify potential supply shortages. A couple from outside the federal government, real quick. We did something with the Australian Defence Force, which was very interesting. They were concerned about the problem of fake news. And what they wanted to do was when they made a press release or released some video or an image or something, they wanted to be able to register that in the blockchain and say, this is the original version. And then we added in a AI system working with a partner that if there was a difference, they would be able to compare it to the blockchain record of the original press release or image or video. And then, as you can see, use a mobile system to compare the blockchain image and data with or video with the potentially faked one and come up with a percent match. So we were providing the original data to be able to authenticate that. And so this stops somebody, say, taking an Aussie video about flying their planes off a carrier and putting, changing the images or causing something to happen. So I thought it was a very interesting project. And then finally, one of the things we've been doing as a pilot with DMV is putting car titles onto the blockchain. We all walk around with all these pieces of paper that we keep stashed at home, so I suppose we don't walk around them, that relate to property we have, to certifications, to licenses. And so what this was allowing you to do is to keep your car title and all the associated information going back to your VIN number on your phone. You could be sure that it couldn't be hacked, it couldn't be duplicated, it couldn't be forged. So very powerful and convenient way of going forward. In effect, what we were doing was actually tokenizing your vehicle. And we ran a pilot with that with a number of with the California DMV and a number of dealers, and we're sort of waiting to see if that gets extended. But our perception was it was very successful. I'd like to talk very briefly about our technology. I'm not going to go deep down to the technology. Some of you have heard this before, and I think when we've presented it before, it just got too complicated. So I'm going to stay at the high level, which is kind of my level. So our big claim: Simba's the blockchain infrastructure development platform for everyone, not just the nerds. Blockchain is the easiest to use, interoperable, secure, persistent, and sustainable API development. So the Blocks platform is made of 12 components, and I'm not going to go through them, but all you can see is there's a lot going on here. There's smart contract design, there's virtual APIs, there's a blockchain that it's going to. There's all kinds of things, and there's a dashboard down there to make life easier. And what it really does is it creates a designer, a way of putting all this together and managing it for you, of creating smart contracts, versioning your blockchain, identifying which blockchain you want to use. And this is enterprise-wide. And then we have these things called solution blocks, which you can see on the left there. And what these are is we've developed sort of kits. Think of a Lego. Think of Lego. You can buy Lego, right, and put it together into a house or a fire engine. Or you can buy a Lego kit, which has a picture of the fire engine on the front, and then you open the box and there's all the bricks you need with instructions. Well, solution blocks are rather like that. So you've got a platform where you can assemble your own blockchain solution, but then you've got the solution blocks, which is a kit that tells you how to build certain common problems: NFTs, supply chain, identity. Now, we are building out these blocks. So I'm not going to say we've got tons. We've got an NFT one right now. We're working on the supply chain one. But our idea is we will build these blockchain solutions blockchains as demand grows, where we see people wanting them. And ultimately, we hope to develop a Simba marketplace where users can develop their own solution blocks and then sell them. So that's the vision. So we got the platform, which is based on a blockchain architecture. You can pick out whatever you want, whatever blockchain you want, whatever cloud you want, whatever, however wallets. Then you've got the platform that helps you assemble that, on-chain, off-chain, all that stuff. And then you've got the solution blocks at the top. So if you sort of log on to Simba, and you can go to our website, and I think there's a free version of it that looks a lot like this, you'll see something that looks like this. Now, this is very important. It's an intuitive drag and drop interface. So what we're trying to do here is put the business and strategic people back into blockchain. We're not wanting to have it stuck over in the corner where the nerds doing it, where you don't really understand what's going on. You know, I always say blockchain is the plumbing, and it's hard to understand the plumbing and see something that you can immediately see the value of. And what you do with this is graphically on the screen, start to compose the relationships you want. So I start out identifying my assets, you know, which are in red there, and then the things that happen to them, which are in blue. You might say I'm creating the nouns, that's the assets, the thing that's going to move through the blockchain, and the verbs, the blue things. These are the things which say what's going to happen. No coding experience is needed to do this. Anybody can do it. Even I can do it. And I haven't coded since Noah was a boy. I think the last time I was coding was Fortran. So it's a ways back. Now, let's see. Yep. So as I say, assets and transactions, what it is and what happens to it. Then you add the parameters for that application. Then you can tell it to dynamically write a smart code. So here you see a little thing of a smart code. It's going to tell me which parameters, the parameter names, and then what's happening to them. So I can use this. This is a little bit confusing here, but what I can do is start to write the terms of the smart code. It's going to include this. It's going to, this is the thing that's going to happen to it. So again, very low code, very easy for non-coders to do. And this supports currently Ethereum, Quorum, Stellar, Binance supply chain, Hyperledger, Avalanche Risk. We will add more as we see demand. We are currently working with Polygon, so you're not locked into anything. And so it's really bringing the developers and the business folks in together to work on something. The initial thing that you're working on of setting it up visually and then starting to set the code up. And then you can generate the code by a simple click. So after I've set up my my smart contracts and I've mapped all the relationships, I hit a button and boom, the code is done. So low code. Now, I would advise you to then get your coders to go in and check it, but it means you can do this very quickly. So if you want to spin up a pilot, this isn't months and months and months and months before you can show management. This is something that you can do, I kind of think, within a week. You know, you sit down with your guys to draw out the business process of the asset, you transfer that into the user interface, you establish your smart contracts, you pick your blockchain, whether it's what's on chain, what's off chain, all of those things, then bang, you got the code. So when you're developing that, when you're getting ready to deploy, first thing you're going to do, it's going to lead you through with these menus, is what chain are you going to use? And you see here, we're picking Ethereum, and we're using a network that is our test network, which we call Circle of Life. I have no idea. Oh yeah, because of Simba. Right. So that's what you do. It's again, just drop down menus, nothing complicated. You pick your file storage. Am I going to be on chain, off chain? What am I going to share, save data to? All of that, very straightforward. Then you go back and you can pull in your smart contracts that you developed. Maybe you've got some smart contracts from a past development you want to reuse. So it's very straightforward, very simple. And then you just name your application and you just hit it and it's deployed. The smart contract contract designer is very important. You create an asset transaction model. You can see here it's got an additive manufacturing component, the things that happen to it: manufacture, deliver, install, receive, and then the design. So it connects all of those together. Then you add the parameters for the app. Again, you know what it is, what's happening to all of these things. And again, it automatically generates the code. Now, I should say, right now, we've pulled this part out of the paid-for app we're using because we're trying to improve it. So for a few months, it's going to be out. And there's another user face in there that's a little bit more complicated. But we're going to add this back in. We just felt we needed to brush it up. But if you look at the free version and the version that you can get, you know, just starting out for like 10 grand to have your guys kind of explore it, I think this is in it currently. And then one of the things that Blocks allows you to do is to deploy to multiple environments using multiple different kinds of blockchains. So, you know, Azure, AMS, all of these, AWS, all of these different things. And what you can also do is search across your relationships. And using GraphQL and DB queries, you can look where the system is touching your IT systems, where it's pulling data, say, out of your procurement system or your HR system, and how those APIs are functioning. And you can write queries such that you can see the entire system running, where the data is coming from, how it's being changed, who's accessing it, because I'm assuming for the government we're talking about private chains, and like, you know, Quorum or something like that, or Hyperledger. You're going to have an administrator who wants to know everything. I know that's a little bit of a step away from blockchain, but let's get real. We're never going to see the pure in the government. And you can set up notifications and subscriptions. So tell me when something happens. And of course, we integrate with Truffle and all of the normal things that you develop in. We're also multi-chain. So we've developed generic APIs for multiple blockchains: Ethereum, Consensus Quorum, Hyperledger Fabric, you know, all of these. And the graph relationships or made up from an asset allow you to track an item across multiple chains. So again, with our project with Boeing and Naver, we were able to track across the government's Quorum version that they were running and the Hyperledger version that Boeing was running. And we could pull data from all of those and we could track what was going on. So very powerful. We're not locking you out or excluding anything. So you see here just a visual of it. That's the diagram that was generated to track all of this. You know, the Quorum part is the Boeing system that then had a whole bunch of data going down about its end stage suppliers that we could pull up. And then we went into different versions of Fabric that were being used by the Air Force, by the Navy, and by and this sort of Quorum 2 acted as a sort of middle thing that was going on between the two. So very, very interesting how we did that across 3 blockchains. So what's next? What do we see starting to emerge as some of the big things in blockchain we think are going to be big in the future? And the biggest thing we think is within AI. And this goes back to the old problem of garbage in, garbage out. No matter how sophisticated your AI is, unless you can depend on the data, what's its provenance? It will not produce usable outputs. So it doesn't matter how smart something is, bad data still makes bad outputs. And this becomes important with model training. So if I'm training my model using good data that hasn't been distorted, that comes from a known source, then I'm likely to get a model that actually produces a useful model that I can use at the end, as opposed to if I'm sort of pulling from bad data that's been tampered with, or I'm not sure where it is, I'm going to create a crappy model. So we think that you need to pay a great deal of attention to the provenance of your data. And similarly for your operating data, so these are just some things that are coming in here. Bad data can dramatically impact the value of AIMS systems. A survey from PwC found 60% of Fortune 500 firms said their data simply lacks sufficient quality to be used in AI and ML decision making. And improving data quality, being able to understand the provenance and lineage of your data can create great cost savings. Within that data, we found, it can be duplicated, counterfeit, or stolen data. It can be incomplete, corrupted, partially damaged, inconsistent or incomprehensible, deliberately tampered with or fraudulently manipulated, or biased and containing unknown prejudices. I worked on an AI ML project for Marines on factors influencing suicidal ideation. And we had a lot of data that was very strongly protected about the characteristics of folks within the Marine Corps. And that data was terrible. I mean, we had people that were identified as 20 different, or not 20, multiple different ethnic groups that frankly made no sense at all. Somebody just clearly checked all of the list. We had contradictory data constantly, and that just radically undermined it. And as AI starts to be used for more decision making, for more situations where the rubber really hits the road, you're going to see the lawsuits fly, and you're going to see demand for being able to understand what's going on. What data did you use to create the model? What data did you use to function? Where did it come from? The AI system might remain a black box, but you're going to need to know where that data came from. And we think blockchain is extremely useful for tracking the provenance of data, being able to create a secure, tamper-proof record of the who, what, where, and when of data that AI and ML systems are using. And we're investing a lot in this now. We think this is really the next frontier of cyber and of data protection. You don't try and hack the system, you try and hack the model, and you hack the model by causing it to be mistrained or by influencing the data it's going to. And you see a little example of how you could track the provenance of medical data on the blockchain for some diagnostic tool. And again, you see sort of another example here. Without a blockchain, I'm sort of working along with my model, and my model comes out with a crappy prediction because a hacker got it in one place, and frankly, the data was just rubbish in another place. So knowing the provenance is very important. And as we see here, with blockchain, being able at the time when I pull data to record where that data came from, and then being able to see who has touched it, what has happened, creates a more accurate, cost-effective model. So we see as AI grows, blockchain can become a vital layer within the AI stack, creating a tamper-proof distributed data management system that can validate and track the provenance of the data from multiple different sources. And this blockchain layer will allow the outputs of data, the outputs of the system to be, much more useful. So we think that blockchain layer is really vital, and we've started to see this in JDAC 2, the Joint All-Domain Command and Control, which the idea is to have massive data input from multiple different nations, our allies, from different sensors, and then to move into something that validates it. And you see this if you look at the actual maps of the model for this. They have there a layer in DoD's maps of this, where they say a distributed data management system for validation of provenance. And we think that system is blockchain. We think it's critical. Then that data can be analyzed, it can be passed on to decide and issue orders, and then back to the execute system. And then that will be tracked also on the blockchain. So you'll have a whole record of where it goes. So we're developing the tools to empower enterprises to obtain the maximum value from their AI/ML investments via blockchain. So Simba is aiming to create a managed data provenance and assured data quality system. So we've seen this work with physical items in supply chain. We've seen it work with digital data in budgeting, in 3D printing. Now we want to take this on to AI, and we're spending quite a bit of our investment money on developing this kind of capability. And we propose to a number of government clients that we explore this with them. And the goal is really to increase the ROI from AI and ML investment. If you spend a lot of money on it and your data's still crappy, it's still garbage in, garbage out. Nothing has changed from the first time you ran a model way back when. So that's where we see a lot of things going. Well, that's it, folks. That's all I have. With 5 minutes left for questions. I'm sorry I took so long, but thank you very much for your time and patience.
Hey, thank you, Tori. This is Josh. So I'm going to go ahead and stop the recording now, and please feel free to ask any questions.